Welcome back. I ended the last video saying we would create a React app with some Redux in it, but let's make one command line app just to get a little bit more used to Redux before we dive into combining Redux with React. I'd like to make a terminal game that mimics the card game Blackjack. So I'm going to make a directory and call it Blackjack, and yarn init this with all the defaults. I'm going to say yarn add Redux. And let's go ahead and open this up in our editor. Now I'm going to make a new file. I'm going to call it main.js. And since we're going to run this one in Node, I'm just going to say, I'm going to get Redux in with require, because Node doesn't play nicely with the import the way I've got it set up on my machine. Now, what are the three things we always need in a Redux application? We always need our store, we always need actions, and we always need our reducer. And if we're building a blackjack game, let's decide what our store should look like for that. So in this game, for anyone that doesn't know, what you have is you usually have a deck of cards, and the cards are all, they're made up of things like you've got the ace of spades, you've got the seven of diamonds, and you've got jack of clubs. And you have many more cards after that. And what you do is, blackjack is a game where the goal is start with two cards. You can hit for more. Try to get 21 or higher than the dealer. And you play with the dealer versus the player, and where each one starts with 2 and hits for more. So if we're keeping track of this, the store, or the actions that we want in our game are, I think we're going to want to have a deck of cards, and we're going to want to keep track of cards for the dealer and cards for the player. And the sort of actions that we want to do are, I want to be able to shuffle this deck of cards. I want to be able to deal the cards. I want to be able to have each player hit for a card. I want them to be able to also stay. Or perhaps fold, if you ever really wanted to just give up. So let's start by making shuffle, deal, and hit. And we need to make, let's see. So generally we would do this by defining the store. Ultimately, I want my store to look like this. I want it to look like a deck, which has an array, and I want there to be three arrays. I want one array to represent the entire deck of cards, and I want the dealer to have a list of cards and the player to have a list of cards. Let's break up each of these actions into what should happen. And I think I'm going to add a initialize. So when the game is initialized, start with a fresh deck. When we shuffle, we should shuffle the deck. And when we deal, we'll say give 2 cards to the dealer and the player. And if we hit, we should give 1 card just to the player. Now if we stay or if we fold, those actually have actions in the game. Let's do that. Let's say stay. Maybe we can say end current hand. Staying and I guess stay and fold. Both of those are going to end the current hand, but they kind of have 2 different ramifications. If you fold, you're basically quitting. If you stay, you are you're basically saying that you still want to stay inside the game. So let's try these ones for now. When we initialize this whole thing, we're going to need a way to create a fresh deck of cards. So let's choose how we want to represent these cards. I'm going to make a function, and I'm going to call it create deck. And when we make a deck of cards, it's constructed out of 4 suits. We have hearts, diamonds, spades, and clubs. And then we also have the face of the cards. And for that, I'm going to say we have a 2, a 3, a 4, a 5, 6, 7, 8, a 9. We have a 10. We also have a jack, a queen, a king, and an ace. And we can create an entire deck by saying that here's a deck, and it starts empty. We can say for suit of suits, remember of is going to give us each of these things. If we did for suit in suits, it would give us an index. I'm going to say for face of faces. What I want to do, I want to make a new card, and I want to say let's take the deck and push on a new card. I want the card to have a suit of suit and the face of this face. And ultimately we can return this deck. So here is a function which returns a fresh, unshuffled set deck of cards. Notice that it's going to be unshuffled because these 4 loops are going to traverse through these rays the same every time. But that's okay. And here on the deck, we're pushing the suit and the suit, the face and the face. Remember that this syntax is saying this is the name of the property, and here's the value of the property. But we can actually use a different syntax. We can use this syntax where we're saying this is the name of it. The name has the variable name, but the value is going to be the actual value of that variable. So now we have a useful function to create our deck. And we have some idea of what we want our store to look like. This is actually just a helper function. So now let's try and create a reducer. I'm going to say create a reducer that accepts actions and returns a new state depending on the action. So our reducer always has state and an action. And we've seen before that the when we use that simple counter application, we know that we want the initial state to be something. When we did a counter, we said the initial state was 0. I want, in this case, we actually have a more complicated state. And what I'm going to do is I'm going to say if, instead of using a default parameter, I want to be a little bit more verbose. So here I want to say if the state is undefined, then we can actually go out of our way to return a initial empty deck and no cards in the dealer's hands and no cards in the player's hands. And instead of having an empty deck, what we can do is we can use this function here to create that first initial deck. So this is some more advanced state than we had with the counter because we have a little bit more shape to our state. And we actually have a helper function which will create a new fresh deck of cards if the first time that the reducer happens, it does not have any of its state defined already. So if the state is undefined, we build it and we get a fresh deck of cards, and each of the players don't have any things in their hand yet. So now let's say if there's another type of action. Let's take a switch statement and say if someone has a type of action which says deal, well, let's consider what we should do here. If we scroll up, we said that if someone deals it, we should give 2 cards to the dealer and the player. So let's do that. We know that the shape of this state looks like this now. We know that there's going to be a deck. And what we want to do is, remember, we don't want to change the deck itself because the store or the state is read-only. So what we want to do is we want to create a copy of the state.deck, and we copy it by using the spread operator so that we get a new array with all of the old elements of the deck. And what we can do now is we can return a new piece of state where the deck is actually the copy, and the dealer has an array of copy.pop, copy.pop, and we can do the same thing for the player. So when we use the word copy here, it's a copy of the initial array inside the state. And this const keyword doesn't mean that we can't modify that copy. The const keyword just means that this variable never changes reference. It means that this variable always have a reference to that array, but we're still able to manipulate that array. It just means we can't ever say copy equals another array. The const will actually prevent us from doing that. So that's actually the deal case for our reducer. We might as well set up the default case, which should be we simply return the state. So if we don't recognize a given action, we make sure to return the state itself, and it just comes out untouched. Let's make another case for hit. So when we hit, we're actually saying that the player should get another card. So we want to do a very similar thing up here, but we definitely want to start by copying the entire deck. And now we want to return the deck should be a copy. The dealer can actually still be state.dealer because nothing on the dealer's side has changed at all. And here we can actually say that the player is now the state, exactly what their cards were before, plus drawing one more deck of cards off of the deck. So we copy the deck, and we give another card to the player. At this point, let's see what this looks like. So we have a reducer where we're able to initialize a deck of cards, and we can deal the cards out, and we can hit and pass it out to the player. Now let's see how we could use Redux in a little terminal application. We do need to say, we need to actually create the store. So we say redux.createStore with our reducer. Let's just double check this. So there's our reducer. The reducer refers to a helper function, and that's all we have. We also have, this really should be in the realm of notes. So now that we've created the store, we can use the subscribe function to react to the store. I think what I want to do here is I want to say console log. I want to show what's in the deck. Oops, I need to plug my battery in. There we go. I think it would be a little bit overwhelming. We don't want to show people really the cards in the deck, but it would be nice to know the deck's length. So how do we access the deck inside of here? Well, what we can do is we can get the state from the store. We can say store.getState. So in the subscribe function, the subscribe function is going to execute whenever the store receives an action and modifies it. So we can ask the store to give us the state, and now we can interact with that. So I'm going to say the deck is the state.deck, and I'm just going to report how many cards are left in the deck. And now I want to refer to the dealer and the player, and it'll actually be okay to, this will just show exactly what cards they have. So let's see what this looks like right now. Well, actually, we should also dispatch some things. So let's say store.dispatch an action with the type, let's say deal, and we can hit and hit. So let's see what happens here. So we can see that when we run the program, we dispatch the deal action. And what that does is we see our deck has 48 cards in it. And the first two cards went to the dealer. And it looks like the second two cards went to the player. We performed a hit action, and that took one card out of the deck. So we went from 48 to 47, and we can see that the player went to having 3 cards. But also we see that the hit happened again, and again we see that the player just received another card. So let's make this a little bit better. Let's do, right now it's not so interesting because we're dealing the cards out from a fresh ordered deck. So how about before we deal, let's build up one more action, which would be to shuffle the deck. So if we want to add a new action, we go to our reducer and we make a new case, and here we're calling it shuffle. In order to shuffle the deck, we definitely want to make a copy of the deck. And we're ultimately going to return the deck will be the new copy, and the, well, you know what, we can actually, we'll say that the dealer still is state.dealer, and the player still has state.player. And there's actually a good algorithm for shuffling the deck. Shuffle the deck by, it's actually called the Fisher-Yates algorithm. Swap every index of an array with a randomly chosen index. So a good way to shuffle cards programmatically, this is just sort of an aside, but a good way to do that is to say, give me every index in this array, and now let's choose a swap index. And we can choose a swap index by choosing a random number scaled by the length of the array. So we're choosing a random number from 0 to 1. In fact, that's what this says. And we multiply it by the copy, the length of the array, and then we force it down. So we're basically picking a number between 0 and the end of the array. Now let's grab the card that lived there in the array, and let's take the copied array at the swap index and make it equal to the copied array at the original index. And now let's go to the original index and replace it with this card over here. So all that we're really doing is pick a random index, swap two cards between current index and random index. Great. So now we're able to shuffle the deck of cards, and the ultimate result is we copy the original deck, we do some manipulation on that copied array, and now we return a state where the player and the copy and the deck, they still have their own cards, but it's shuffled. So now if we run our program again, instead of seeing this ace, king, queen, jack, 10, 9 business, we should see it be more random. So there we go. Initially we shuffled, and that initialized our state where we had a deck with all 52 cards. And now when we dealt it, we can see that there's actually much more random cards. So this is a good start for an engine of a blackjack game. What you can see is Redux is responsible for defining how we interact with our data. So this before we plug this into React, this is just sort of a case study of Redux itself. So in Redux, all that we do is we choose the initial state, the initial shape of our state, and we choose what sort of actions we want to do. So in this case, we have, well, we only have 3 actions so far. We can deal cards, we can shuffle cards, and we can add another card to the player. And you can see that if we follow this paradigm, it gives us a very clear-cut, very rigid way to think about our application. In fact, let's create one more action. I want to call it reset, or I suppose I'll call it fold. And let's annotate that up here. So we initialized it. That really just kind of happened automatically. Let's say, well, I feel like maybe even turn in is better. Like I'm trying to describe when you finish a round. Maybe I'll just call it finish round. Finish hand, turn all cards back to the deck. So I'm going to call this not fold. I'm going to call it finish hand. And what we should say for this is, well, we can return something where the deck is equal to an array, and the deck consists of everything that was in the deck and everything that was in the dealer's hand and everything that was in the player's hand. Meanwhile, the dealer now has an empty hand and the player now has an empty hand. So now we can say, if we ever finish a hand, we can reset the game and put the cards back in the deck. We could reshuffle the deck and we could play another hand. So let's see how this works. So right now we're shuffling, we're dealing, we're going to hit 2 cards, and then we're going to say store. We want to dispatch that action where we said finish hand. And now we could do it all again. So let's see how this works here. So we started with the deck and we shuffled it, which initialized it. We dealt out 4 cards, 2 to the dealer, 2 to the player. The player in this case hit 2 times. Well, they hit once. They went from 2 cards to 3 cards. And they hit again. And we finished the hand. Then we shuffled a new hand. And we dealt the cards. And the player hit once. And then we finished the hand. So you can see here that what Redux really gives us is our entire application state is inside this store. And when we subscribe to that store, we have a way to investigate the data there. For instance, here we're seeing how many cards are left in the deck. We're seeing how many cards, we're seeing what cards the player has, what card the dealer has. And the only way that we interact with the store is by dispatching events. So what Redux offers us is the ability to store all of the state of our application in one place, and it forces us to interact with that information via these actions. So all that we're really doing is we're sending messages to the store we're dispatching actions, and those actions are very well defined, and our application only reacts to those things.